Hello, welcome back to Dr. Zahid Math. Today we are going to learn how to approximate a function value using interpolation polynomials. We have the function f of x equals log 3x minus 1 to the base 10, and we will construct linear and quadratic polynomials to find an approximate value for f of 1.4. Linear and quadratic. I will tell you, the word is not in the question, how it is coming as linear and quadratic. And by the end of this video, you will see how easy it is to find the absolute error as well. Let's get started. What is given? Let me read the question. For the given function f of x equals x0 equals 1, x1 equals 1.25 and x2 equals 1.6. They ask you to construct an interpolation polynomial, right, of degree at most 1. What do you mean by at most? In 001, you studied this English word. What is at most? Which is no more than. At most means what? The English meaning? No more than. No more than means what? Not at all big. It is small. It means what? Less than or equal to. So at most 1 degree and at most 2 degree. If it is at most 1 degree means what? Maximum 1 degree, right? So that means what? It is linear. And at most 2 degrees means what? It is quadratic, right? It is power 2. Degree means what? Maximum, or you can say highest power, right? So let's start this question. For this, you need this formula, Newton's divided difference formula. F of x equals y0 plus x minus x0 and del y0. Usually for divided difference, you have to put a line in the middle. Just remember, you have to put a middle line. Sorry, it is not coming in a good way. Let me write here, f of x equals y0 plus x minus x0. You have to write like this, del y0 plus x minus x0, x minus x1, del square y0. You have to put a line in the middle, and then plus x minus x0, x minus x1, x minus x2, and then del, you have to put a line in the middle, del cube y0. So what we are going to do, this del normally we use for equal intervals, but also you can use it, nothing wrong in that, but still always I use different dels. For equal intervals, I use normal del. For this divided differences, I just use a line in the middle. We call it as cross delta, but it's okay. You can use it as long as you are very clear with the definition, and moreover you have equal intervals is not in your syllabus, right? So let's start this question. Let us go to the solution, right? So in the solution, first I need to create a table. First of all, what is given? x0 is equal to 1 and x1 is equal to 1.25 and x2 is equal to 1.6. And what is your function given? F of x equals log 3x minus 1 to the base 10, right? So now let me create a table, very clear table you just create. Yes. So I'm going to create x values, right? It is 1, 1.25 and 1.6. And your f of x is log, right, f of x is equal to log 3x minus 1 to the base 10, right? So we are having 1, 1.25 and 1.6. Take your calculator, all of you. Please type this equation. Type this equation and then press calc. Put the point x is equal to 1. You get 0.3010. And then put x is equal to 1.25, which is equal to 0.4393. Fix the calculator, 4 decimal values. Teacher, it is not given any places. If it is not given, always keep 4 decimal places. And fix it for 1.6. Calculate x is equal to 1.6. You will get 0.5798. So we got the table. This is your x and this is your f of x. So if you want to use this formula, you want this del y0 and del square y0 and del cube y0 you want. What is this? How you will get it? You will get it from the divided difference table. So first we need to create divided difference table. So step number 1, divided difference table. divided difference table. So first we are going to create a divided difference table. So we are going to create x and y and delta y and so on. It keeps going. So your value is 1, 1.25 and 1.6, and your y values are 0.310, 0.3010, and the next value I didn't remember, 0.43935798. Okay, so 0.4393 and 0.5798. So we are going to create del y. I told you how to create del y in the last video. If you did not watch the last video, please go back and watch it and then come to this problem. It will be so easy for you. So del y, we are going to create this minus this, which is 0.4393 minus 0.3010 divided by 1.25 minus 1, 1.25 minus 1. So which is equal to and 0.5532, right? And the next value will be 0.5798 minus 0.4393 divided by, right, 1.6 minus 1.25, which is equal to, put in the calculator, which is 0.4014. I keep, you can say stop the video I'm doing and then again I start the video so that the time will be saved. The next I'm going for del square y, right? Del square y will be what? These two values you are going to subtract, which is 0.4014 minus 0.5532 divided by, I told you 1 down, you have to start from here. So which is 1.6 minus 1, which is equal to negative 0.2530, right? So let me write these values again. So this is your x and this is your y, this is your delta y and this is your delta square y. So it's 1, it's 1.25 and 1.6, 0.3010, 0.4393 and 0.5798. And what 5798, sorry, 0.5798. What's your delta y, which is in between this 0.5532 and in between this 0.4014 and in between this negative 0.2530. So you are going to take the values especially in this order, the slanting row. The first row you are going to take it. So you are going to take it the slanting row. Sorry, I'll put it as dotted line. Maybe my lines will not be good. So better I use, sorry. Okay. Better I use this one. Yes. So this is the value. I'm going to use it for the Newton's divided difference formula. So these are the values I'm going to use it. Okay. So this is your x naught, right? Let me write the values also. And this is your x naught. This is your x1, x2, y naught, y1, y2. And this is your delta y naught. And this is your delta square y naught. Okay, right. So all these values are ready. So I'm going to use now Newton's divided difference. Okay, Dr. Zahir, how this will come as interpolation? Look, the question. The tables are 1, 1.5, 1.6, right? And what is the question they are asking? They ask you to approximate f of 1.4. Where is 1.4? Look here. 1.4 is inside this table. So it is interpolation. Okay, keep in your mind. So I'm going to use Newton's divided difference formula, right? So Newton's divided difference formula. Newton's divided difference formula. So the formula already I've given on the top, but anyway, I'll write it again. So which is given as f of x is equal to, right, y naught plus x minus x naught delta y naught, there is a line in the middle, plus x minus x naught and x minus x1 delta square y naught, and it is going on. But for you only up to delta square y naught, okay? So f of x equals your y naught. It is the first value which is here. 0.3010 plus x minus x naught, which is 1. And delta y naught is this one, 0.5532, and then plus x minus x naught, which is 1, and x minus x1, which is 1.25. sorry, let me write 1.25 properly. 1.25, and delta square y0 is this value, which is negative 0.2530. Right? So we got the Newton's divided difference polynomial. You can say this is interpolating polynomial or interpolation polynomial. You look here, how many terms are there? There is one term here with linear, and there is one term with quadratic. How can you say this is linear, teacher? There is only one term, which is x minus 1. So this is linear. How can you say this quadratic, teacher? X multiplied by x is what? Quadratic. What is quadratic? Power is what? 2, or the highest power. That means the degree is 2. Right. So let's go to the question now. So the question again I'll read. So just carefully listen. Construct an interpolation polynomial of degree at most 1 and degree at most 2 to approximate f of 1.4. So you are going to create the polynomial first. Already we created. So step number 2. So step number 2 is constructing a polynomial. So we are going to construct a polynomial, right? So construct a polynomial, right, of at most 1 degree. Of at most 1 degree. At most means what? Maximum. At most 1 degree. And then what we are going to do? To approximate. So to approximate f of 1.4, that we are going to do it. Yes. So let us start now. So your f of x is equal to what? 1 degree polynomial. So this is 1 degree, right? And this is going to become what? 2 degree. You can say like that. So this is 2 degree. So what is your thing? 0.3010 plus and then x minus 1. Teacher, the constant term will come. Yes, of course, constant term is degree 0. That is power 0. So which is x minus 1 times, which is 0.5532. Okay. So now what we are going to do? We are going to calculate f of 1.4. This is the value they ask you to approximate. So put x is equal to 1.4, which is 1.4 minus 1, 0.5532. So f of 1.4, which is an approximate value. Keep in your mind, this is not a true value. This is an approximate value, which is equal to 0.1.4 minus 0.5532, which is equal to 0.5223. So this is your approximate value. For this one, look at the question. You are going to calculate what? The absolute error. After doing this, you are going to calculate absolute error. So let me calculate absolute error. What is the formula for absolute error which you studied in the introduction module? Absolute error formula, do you remember? So absolute error is equal to, which is absolute value, right? So the formula which I given in the first video is true value minus approximate value. True value minus approximate value. So we got the true value? No, we have only approximate value. So let us calculate the true value, right? What do you mean by true value? The exact functional value, right? So true value is f of x equals what? Log, right? And it is base 10, 3x minus 1. So which is equal to log base 10, 3 times multiplied by 1.4 minus 1, which is f of 1.4 I am going to calculate. So when I put in the calculator log base 10, 3 times 1.4 minus 1, which is equal to 0.5051. So this is f of 1.4. This is the true value. True value means directly we are calculating from the function. So we got true value and we got approximate value. So now we can calculate absolute error, right? So therefore absolute error for polynomial of degree 1, right? Yes. So absolute error is equal to approximate value, true value. How much is true value? Which is 0.5051 minus what is approximate value? 0.5223, which is equal to, let me put in the calculator, in the 0.50 minus 5223, I'm getting negative. So negative 0.01721. So absolute value of negative is positive. So 0.0172 is the absolute error for polynomial of degree what? 1. So this is the first question answer. There are 2 questions are there. Right. Let's go to the B question, which is step number 3. So let's go to step number 3. What is step number 3? Step number 3, we are going to construct an interpolation polynomial, right? We are going to construct an interpolation polynomial, right? Interpolation at most degree 2, right? At most degree 2. Already we calculated only degree 2, only maximum. And then approximate what? And then approximate f of 1.4. And also find what? And also find what? You're going to find out absolute error. So also you calculate absolute error. Let me write in the step 2 also. Calculate absolute error and then calculate absolute error. Also absolute error. So all these things we calculated here. So same thing we are going to do it. Yes. So let us take the whole polynomial. Look here. This is the whole polynomial. This is degree 2. This is degree 1. So when I take degree 2, it means degree 1 is included. So we are going to take the whole things, which is f of x is equal to, right? So f of x is equal to 0.3010 plus x minus 1, 0.5532, right? And then plus x minus 1, x minus 1.25, and then with this negative 0.2530. Right, now in this we are going to put f of 1.4. If I put f of 1.4, I will get 0.3010 plus 1.4 minus 1, 0.5532, and then plus 1.4 minus 1, 1.4 minus 1.25, and then minus negative 2.530. So if I put all these things in the calculator, I am getting 0.5071. Okay, right. 5071. So this is the approximate value. This is the approximate value, right? So we already got the true value, but the true value is same, right? Just now we calculated, which is 0.5051. So the true value is equal to, how much is it? I forgot it. 0.5051. Yes. 0.5051. So now we are going to calculate what? Absolute error. So when I calculate absolute error, right, which is equal to absolute value, true value minus approximate value, right? Yes, this is a formula. So this equals, true value is 0.5051 minus approximate value is what? 0.5071. So which is equal to, put in the calculator, 0.5051 minus 0.5071, 0.0020, right? 0.20020. So this is your absolute error.